You're about to see one of the most dangerous physics lessons ever taught. A professor stands in front of a lecture hall, holding a heavy metal ball, and then he lets it go. But what happens next defies every instinct we have. The ball swings away, fast, powered only by gravity. As it comes back toward him, it's moving at full speed, straight for his face. The students freeze, but Professor Walter Lewin doesn't even flinch. Why? Because he trusts physics more than fear. This is a perfect example of the law of conservation of energy. When the ball is lifted, it gains potential energy stored due to height. When it's released, that potential energy converts into kinetic energy of motion. But here's the key: no energy is lost, only transformed. So the ball can never swing higher than where it started. That's why it misses his face by millimeters every single time. Physics isn't just numbers, it's trust in nature's rules. Walter Lewin didn't risk his life. He proved that energy follows order, even when chaos looks certain. Every falling apple, every orbiting planet, every crashing wave obeys this same invisible law. The universe wastes nothing. Energy never dies, it just changes form. And sometimes, all it takes is a swinging ball to remind us how beautiful that truth really is. Then check this out.
I have here a pendulum. I have an object that weighs 15 kilograms and I can lift it up 1 meter, which I have done now. That means I've done work. MGH is the work I have done, believe me. I've increased the potential energy of this object. 15 times 10 to about 150 joules. If I let it fall, then that will be converted to kinetic energy. If I would let it swing from 1 meter height, and you would be there and it would hit you, you'd be dead. 150 joules is enough to kill you. They use these devices, called a wrecker ball. They use them to demolish buildings. You lift up a very heavy object, even heavier than this, and then you let it go, you swing it, thereby converting gravitational potential energy into kinetic energy, and that way you can demolish a building. You just let it hit, and it breaks a building. And that's the whole idea of wrecking. So you are using then the conversion of gravitational potential energy to kinetic energy. Now, I am such a strong believer of the conservation of mechanical energy that I am willing to put my life on the line. If I release that bob from a certain height, then that bob can never come back to a point where the height is any larger. If I release it from this height and it swings, then when it reaches here, it could not be higher. There is a conversion from gravitational potential energy to kinetic energy back to gravitational potential energy, and it will come to a stop here. And when it swings back, it should not be able to reach any higher, provided that I do not give this object an initial speed when I stand here. I trust the conservation of mechanical energy for 100%. I may not trust myself. I'm going to release this object, and I hope I will be able to do it at 0 speed, so that when it comes back, it may touch my chin, but it may not crush my chin. I want you to be extremely quiet, because this is no joke. If I don't succeed in giving it 0 speed, then this will be my last lecture. I will close my eyes. I don't want to see this. So please be very quiet. I almost didn't sleep all night. 3, 2, 1, 0. Physics works, and I'm still alive.
If this experiment blew your mind, imagine what's next. Subscribe to Sea Fishing, where curiosity never stops swinging.